Hello, this video is on Operations Management BANA 3000 Section E01, Spring 2021. This is Week 3, Aggregate Planning. So let's bring up the lecture notes. And aggregate planning is Chapter 13 in the text, beginning on page 541. Now, the development here will deviate from strictly what the text follows and include material beyond the text. The intent of doing this is to simplify the calculations so the concepts can be better understood. Also, not all the material in Chapter 13 will be covered. So what I'm covering here is to emphasize the basic concepts, not the details of implementation. So it'll be a very large introduction to aggregate planning. Now the chapter outline here is, here's the page numbers, the beginning page number, and these are the different titles. Now, in this lecture, in this course, page 544, the planning process, background only. The nature of the aggregate planning is background only, and I will include information here that the text does not include. And then the aggregate planning strategies. Some of those will be covered, some will not be covered, and I'll cover 4 of them. The methods of aggregate planning, this will be covered, but I will modify how I cover it to try to make it more understandable about the concepts and less about the details of implementation. And finally, next is the aggregate planning services and yield management. This is not covered in this lecture, in this course. Okay, now as we go through here, the planning process, background only, aggregate planning is the same as aggregate scheduling. So notice the title of the chapter in the textbook is aggregate scheduling. Well, aggregate planning is the same thing, it's just a different name. And you are scheduling and you are planning, and so you're planning your schedule. Although the text says the objective of aggregate planning is to meet forecasted demand while minimizing cost, I will disagree with that. That minimizing cost could be one objective, but it's not the only objective. And sometimes cost is not what you want to minimize. Sometimes that's not your objective. A better objective of aggregate planning, and the objective to use in this course, is to balance the forecasted demand with operations to achieve strategic goals. And one of those goals may be minimize cost, but there are other goals. Cost is not the only objective and not always the most important objective. Also, the primary output of an aggregate plan is the production plan. Therefore, aggregate planning, in addition to aggregate scheduling, can also be called production planning or sales and operations planning, and it's called a number of other titles as well. Okay, 545, the nature of aggregate planning. This development that I'm in this course will not cover disaggregation of the aggregate plan to the master production schedule, then to the MRP, the material requirements planning, then to scheduling. What I will cover in here is the MRP separately, and then I'll cover scheduling. Okay, next, the aggregate planning strategies. Some will be covered. The detail, number of strategies, and overall development of the aggregate planning strategies will differ from the text. An introduction to the basic concepts of aggregate planning. Only 4 distinct strategies will be covered in this development. Chase demand, level capacity, chase demand with overtime, level capacity with overtime. And these 4 will give you a good foundation and good indication of what can be done with aggregate planning. And these are only 4. There are many, many different strategies that you can implement. Okay, to summarize, chase demand and level capacity, I will define these and also emphasize the characteristic that demand variability is described by the capacity. Level capacity, the demand variability is described by the inventory. Chase demand with overtime, the labor and inventory managed by the overtime. Level capacity with overtime, the labor and inventory managed by overtime. So these are the characteristics I will be covering in this lecture below with some examples. Next, the method for aggregate planning is covered but modified. And the methods in this text provide more detail than I will introduce, develop, or require you to know. And the reason I do that is because the detail that they give you, it is very good detail, but if you understand the basic idea of aggregate planning, then that detail is not difficult to apply. The important thing is to understand what aggregate planning is doing. I will focus on the main principles and concepts without concern for detail that can change with the application in different industries and companies. The way it's done in the textbook is not done in all companies. It can be done very, very differently in different companies. Techniques change, but the concepts do not change. And finally, the aggregate planning and services and yield management, I do not cover them in this development in this course. Okay, so introduction to the strategies. Aggregate planning strategies manages the relationship between the four primary elements: capacity, productivity, forecasted demand, and inventory. Okay, let's describe these. Capacity. Capacity will be defined by labor and measured by an FTE, which is a full-time equivalent. Now, a full-time equivalent FTE means a full-time equivalent person. Now, it's not necessarily a person. It could be a person, but it's a full-time equivalent worker. So one FTE, one labor of FTE capacity, it could be one worker working 100%. It could be two workers, and both are half-time. It could be three workers working 1/3 time. It could be five workers working 1/5 time. And so this is not how many people you need. It's how many labor capacity you need. And the labor capacity is measured by FTEs. Next is productivity. Productivity is the output of capacity that either meets demand or builds inventory. Productivity can come from both regular time production or regular time labor or overtime labor and overtime production. So productivity. So a labor, one FTE will generate units of output. And those units of output are called productivity. And so regular time is that they're working regular, and our regular time metrics here will be a 40-hour work week. So regular time, they're working regular 40 hours a week. Now, overtime is the same FTE. We don't change the capacity, but we change the productivity of an FTE or of capacity by let them working overtime, more than 40 hours a week. So the regular time is the standard time for an FTE. But that FTE, or people, or however many there are, can work overtime, and so the productivity can be more than just one FTE. So one FTE can produce more than just one regular time output or productivity. They can produce regular time and overtime. Next is the forecasted demand. Demand is satisfied from either inventory or the productivity of the capacity. And finally, inventory. Inventory satisfies demand. Okay, 4 aggregate planning strategies will be presented and analyzed. Here we go. Chase demand. Capacity follows demand. Demand variability impacts capacity. Level capacity. Capacity is constant. Demand variability impacts inventory. And then chase demand with overtime and level capacity with overtime, where the productivity is variable because of overtime. But the capacity doesn't change, but the productivity of the capacity changes. And inventory is managed by overtime. Okay, consider the relationships. Here's the concept underlying aggregate planning. Level capacity. If the capacity is level and the productivity is level, since both of these are level, if the forecasted demand decreases, then the inventory increases. Now think about that a minute. That should be logical. Your capacity is level, your productivity is level, you're producing 100 items every single week. But your demand goes down. If the demand goes down, then where's all that productivity going? It's going into your inventory. So if the demand goes down, the inventory goes up. Conversely, if the capacity and labor are level and the forecasted demand increases, then the inventory decreases because they're inversely related. Now, the addition or overtime will affect the productivity here, not the capacity, and consequently will change the inventory. Or consequently will affect the inventory. Okay, that's level capacity. Now, consider change demand. Okay, if the forecast demand and the capacity increases and the productivity increases, then the inventory level the inventory will remain level. Well, it'll remain level if the demand increases and the capacity and productivity increases the same amount. In other words, if the forecast increases by X amount and then the productivity increases by X amount, well, that productivity will meet the demand. So the inventory then remains level or constant. It doesn't change. Or if it decreases the same amount, inventory remains level. So the concept between forecasted demand, capacity, and productivity and inventory, those four things, those four elements, that's what aggregate planning captures, manages, and creates some very powerful strategies. Let me emphasize, note, level capacity and chase demand are defined by capacity, not productivity. And you'll see this below in the four examples. Okay. So now let's look at some examples to see how this is applied. And as I go through these examples are very similar to the homework. The homework comes right from this lecture. Okay, first of all, to illustrate the concepts, consider the information, data, and parameters. Okay, notice I have here labor, and then finally inventory. So let's talk about labor, because that's our capacity. That's what's producing items or units to satisfy demand. First, regular time. Well, regular time refers to labor working 40 hours a week, 48 weeks a year, 12 months a year as the standard. Now notice there are 52 weeks in a year, but the standard for this particular application is 48 weeks in a year. So what happened to the other four, 48 to 52? Well, we have 4 weeks of vacation. And so your FTEs have 48 productive weeks and 4 weeks they're not productive. And there's where the standard comes in. And they're working a 40-hour week, and they're working all 12 months in the year. Okay? But they can take 4 weeks off somewhere, anywhere. Therefore, the regular time results in 160 hours per month. Now, what this regular time means, or the FTE time, is if I take 40 hours a week times 52 weeks divided by 12 months, the amount of hours per month is going to be 160. So the regular time, the FTE time, is 160 hours per month. And so this is for regular time, but this is referred to as FTE time or FTE regular time. Well, labor that works regular time is called an FTE, full-time equivalent. 1 FTE is equivalent to 1 worker. And overtime, contrasted with regular time, is an FTE working more than the standard 40 hours a week. Okay, so they're going to be working more than 160 hours a month. Okay, next is called, so that's the FTE time standard. Next is the labor standard. Well, the labor standard is given to be 1.6 hours per unit. Well, notice this is how much 1 FTE, how much time it takes 1 FTE to produce a unit of output. So that's a standard of production. It's called labor standard because your labor is being used, 1.6 hours of labor to produce an output. The labor standard is the standard time it takes for 1 FTE to produce 1 unit of output or product. Closely related to that, and that's given, that's always given. Next is a production standard, PS. And notice it's going to be the amount of FTE hours divided by the labor standard. So therefore, the production standard equals 100 units per month. Well, notice, first of all, notice the units here, hours per month, hours per unit. okay, when I divide that, it'll be units over a month. The hours cancel out. Okay, now what this means is if an FTE can work 160 hours during that month, that's one FTE time hours within a month. But every 1.6 of those hours will produce a unit. So if I take the 160 divided by 1.6, which represents 1 unit, then that will result in 100 units. The production standard is the standard output or productivity of 1 FTE during a month in this case. In other words, the production standard could be a production standard per month, it could be a production standard per week, production standard per quarter, per year. You could have any time. And what you would do is you have hours per month here, hours per year, hours per quarter, hours per week, whatever you want to put there. And then your production standard will be relative to that time. Okay, next, now costs. Regular time unit labor cost here. Start with wages, $10 an hour. I'm using a round number here. Overtime wages is $15 an hour. Well, since this is 50% more than 10, okay, this is commonly referred to as overtime is time and a half. And I'll use that term because it's pretty common, time and a half. In other words, if you're getting paid $10 an hour and you work overtime more than 40 hours a week, so if you work 50 hours a week, well, 40 hours are $10 per hour, but the other 10 are $15 per hour, so they give you a reward for overtime, and this is time and a half. So what if the overtime was double time? Well, the cost would be $20 an hour. Those are common terms. Okay, now, the regular time unit labor cost, well, the $10 an hour times my labor standard of 1.6 hours per unit. Now, I'm multiplying this, so the hours cancel out. It's going to be cost per unit. The regular time unit cost is $16 per unit. In other words, it takes a regular time FTE, it costs us $16 for that FTE to make 1 unit of output. We're paying $10 an hour, but we're also paying $16 per unit of output. Overtime, which is time and a half, will be 24. And we can either take 15 times 1.6 or just 1.5 times 16, which would be 24. Time and a half. So now we have regular time unit labor costs per unit, overtime unit labor cost per unit. Finally, we have the carrying cost. Now the carrying cost here is the inventory unit carrying cost to carry 1 unit of inventory. And here it's $5 per unit per month. And notice I have C sub C. We'll see this C sub C later in inventory control. But I'm putting it in here for a view for the future. But the big C is cost, the little c is carrying cost. And all this means is that if I'm carrying inventory, then it pays to carry inventory. I have to store it. I have to pay people to store it. I have to have warehouse cost. I have to have accounting cost. So it costs money. And so we prorate this over a unit and over time, and it's $5 per unit per month. And this is prorated over units and time. Okay, now for this example, now that we have all this information, then the example is going to be using these units for 6 months. And this is the actual forecasted units that are in the textbook. So I'm using the textbook. I'm using most of these values in the textbook, but I did change, let's see, I changed the overtime cost here. I did change this to $15 an hour, time and a half. Okay, now use this example below to illustrate the 4 aggregate planning strategies and their characteristics. Now, before we get into it, there are 2 requirements. No negative inventory is allowed. Negative inventory is called stock out. Stock out occurs when there is unmet demand or demand that occurs and there is no inventory to meet the demand. That's called stock out. And notice stock out does not mean 0 inventory. That means you have demand, but you do not have inventory to meet that demand. It's unmet demand. That's stock out. Also, the second requirement is to require 0 for the beginning and ending inventory, annual inventory, or the beginning and ending inventory for a planning horizon. Now, this planning horizon is 6 months. It could be 2 months, 5 months, 6 months, 10 months, 12 months, 18 months, whatever your planning horizon is. But in this example here, we are requiring the beginning of our inventory to be 0 and the ending of our inventory to be 0 at the beginning of this 6 months and the end of the 6 months. The beginning and ending inventory can be other than 0 for sure, and they don't have to be the same. But that goes beyond this lecture in this course. Okay, so let's look at these four. We're going to do chase demand and level capacity, chase demand with overtime, the level capacity with overtime. So let's do it. Here we go. Okay, first of all, chase demand, I've copied this, and so I'm going to illustrate this below. Consider the forecasted demand, capacity, productivity, and inventory summary from Excel below here, and I've copied it. And we'll talk about this in a minute. For this development, begin with 0 inventory, end with 0 inventory, no negative inventory is allowed. And so right here is I've began with 0 inventory, I've end with 0 inventory, and there's no negative inventory allowed. Good to go. Okay, so here's how we're going to do this. And this really kind of illustrates how we'd go about actually doing this. Okay, now I could talk about it, but I want to show you how to do it with in Excel. Okay, so here, let's bring in Excel. And I've copied all the information here. This is an Excel spreadsheet. And I have, here's my 4 down here. Here's my 4 different aggregate plans. Here's my inventory cost. Here's my labor standard. There's my production standard. There's my regular time unit cost here. Here's my chase demand. Okay. So the reason I'm showing you in Excel, because you can actually see how to calculate these things. And this will be used in the homework. Okay. Now this column this row right here, I say column number, this row right here, like 1, this is column 1. 2, this is column 2. Column 3. So this right here represents the column numbers. Here's column 4, 5, 6, 7, and 8. Now like 2 here, 2 equals 1. So this is chase demand. For this course, a very simplified way to get a chase demand production is just let the production here equal the demand. And that's what I'm doing. So all I'm doing here, let's zero this out. All I'm doing is say I want this to equal this. Actually, I can actually just copy this down, all the way down, and there it is. Now 3 is my production standard. So this, I can zero this out. This, I just says I want that to equal my production standard, which is 100. There it is. And I want all these others to equal that too, so I'll just copy that down. And there it is. Now my labor, this is my FTE requirements. My labor capacity. Well, notice 2 over 3, it's going to be your production divided by your production standard. Okay, so let's zero these out. And very simply, it's going to equal 2 divided by 3. 2 divided by 3. I need 8 FTEs in the first month. Here, I have 700 divided by 100. I need 7 FTEs working throughout the second month. How many people do I need? I could have 7 full-time workers. I could have 14 half-time workers. But I need 7 FTE capacity, labor capacity. Then I can copy that down for the rest of the other, all 6 months. So there's my capacity. This is my capacity labor requirements. That's what I need. Okay. Now my regular time unit cost. Remember up here it was $16 per unit. And so let me just zero this out. Let me say this is going to equal my 16 up here, and there it is. And then I'll copy this down each time. Now, what's my regular time total cost here? It's 5 times 2. It's how much I'm producing times how much it costs to produce each unit. So these are my units. And that's my cost per unit. There's my units, my cost per unit. Let me zero these out. So this simply equals the cost times my production. And there it is. Same thing here. My unit cost times my production amount. I can copy that down. And there it is. Okay. Now, I'm going to set this up, and down below, chase demand, they're all going to be 0. But let me show you how to set it up. First of all, let me just delete these. Let me show you how it works. This right here is 0, because that's required. Let's see up here. That's required. Now my ending inventory right here, it's going to be, this is column 8, it's going to be 7. It's going to equal my beginning inventory plus my production. My production is right here. That's going into my inventory. Minus my demand, it's coming out of my inventory, return, and that's my inventory ending. Now the beginning inventory of the second month equals the ending inventory of the first month. And the ending inventory of the first month, again, is the beginning inventory of that month plus the production minus the demand. Well, notice I can just copy these down like I have before, and there's all my zeros. But notice these two numbers are the same, so if I add this and subtract this, it turns out to be 0. So these are 0. For chase demand in this course, the way we're doing this, these will be 0. Level capacity, they will not. Okay. Now, the costs. Well, I can sum the demand. I'm summing the demand here. I'm summing the production. And I know that the cost per unit is $16. So there's my unit cost. Here I can just say equals 16 times 6,000. I get 96,000. Notice this and this should be the same. And that's why it's in the same box here. Whether I calculate it in aggregate or I calculate it each individual time period, I've done the same calculations in different order. It's a quality check. Make sure you've done it right. Okay, that's chase demand. Let's go to level capacity. Let's bring the, so what I did here, these steps right here is exactly what I did. Okay, so now let's go to level capacity. Oh, let me back up here. Notice that capacity of chase will follow the pattern of forecasted demand. So notice these two here follow one another. They call chase. They chase one another. They don't always equal. In this case, they do equal. In this course, they'll be equal. Not necessarily. In this course, they may be equal. They may not be equal. But they chase it. Okay. And then here's my capacity. So chase demand is defined by my labor. Now, therefore, the inventory remains level, and notice it's very level. So all the variability in demand will be seen in the production and the capacity, not in the inventory. Okay, level capacity. Okay, again, consider the forecast demand, capacity, productivity, and inventory summary from Excel. For this development, beginning inventory is 0, ending inventory is 0, no negative inventory is allowed. And again, here's my 7 steps. And so let's go to Excel and show you how to calculate these things like we did before. So let's come down to level capacity. Now we will have inventory over here. Okay, make this a little bigger so you can see it. I'll move it around. There we go. Okay, so here's our forecasted demand right there. That's copied in. There's my sum. Okay, in other words, equals sum. I sum all these. Okay, now, what's my production? Well, a good description of a level capacity production equals the average of all the demand. If I average all the demand, hey, that's a production. I'll let every time period equal that average, and there's my production. So therefore, when I sum this up, notice I'm producing exactly what I need. I'm just doing it in a level fashion. Again, my production standard is 100. Again, I copied that from up here. And then my FTE requirement, my labor requirements here, is my production divided by my production standard, which is 10. So I need 10 FTEs every single time period. And notice how level that is. That's the definition of level capacity. Labor is my capacity, it's level. There's where you define level capacity in the labor, in this example. In this course. Okay, what about the costs? Again, our unit cost from above is 16. We've done that before. And so all I need to do is multiply 16 times my production to get my regular time total cost. That equals 16 times 1,000, which equals 16 times 1,000. I could do the each time, or I could just copy it down. Okay, now I can take that 16 down here and just say 6,000 times 16. Whoops. There we go. Is 96,000, and those numbers should be the same, and they are. But now we have inventory. Let's come over to inventory. Okay, let's look at our beginning and ending inventory. Our beginning inventory is 0. Actually, let's zero this out. Let me work it here. So that's a 0. And this is going to equal my beginning inventory plus my production. My production over here is going to be right here, minus my demand. Return. Same thing, do it here. Oh, and the beginning inventory here equals the ending inventory of the first time period. We'll do it again. Equals the beginning inventory plus my production in this month is here, minus my demand. Now I can copy both these down at the same time, and there's my results. Okay, now to get my cost here, I want to take my average of my inventory. Now, all you need to do is take the average of the ending inventory, but to be safe, in some of the more advanced applications, it's much safer to take an average of all of the data, beginning and ending, and that's really the average of all of your inventory. If I average the ending inventory, it would be the same number, but I think it's safer to average everything. Now my unit cost, since this is an average, my unit cost up here, let's see, where's it at? $5 per month, but this is over 6 months. So this is going to equal 6 months times, I did that again, times the $5. Okay, so it's $30 per year, because this 400 is not carrying it over a month. It's the average carried over the entire year. It's average carried over the 6 months, over the planning horizon. So therefore, it's $30 to be carried, one item to be carried over this planning horizon. On the average, it's 400 carried over this planning horizon. Each one costs $30 to carry over that planning horizon. The total cost then equals 40 times 30, which is 12,000. Now, I don't ask you to do this in the homework, but I'm going to do it anyway here, just to show you how to use all this information. Okay, what I'm doing here, let's go ahead and delete these out and delete these out. Okay, what I'm doing here, let me take the average inventory in each time period. In this case, it's a month. Okay, in other words, average of the beginning and the ending inventory in that time period, which is a month. Okay, and then copy that all the way down. Now I know that on the average, I'm carrying 100 items through that month, but my carrying cost per month is $5. Okay, per unit. So here my cost then is going to be 5 times how much I'm carrying, equals 5 times how much I'm carrying. Copy that down. So if I sum this, now these are the costs for each month in this planning horizon. I can sum the total cost, and there I'm doing it. And notice the 12,000, those should be the same. Again, quality check, make sure the numbers are all correct. Now, this just gives you the cost of the planning horizon. This gives you the cost of carrying items within that planning horizon. So it gives you more granular information for cash flow, more information to actually manage your inventory, because you know exactly how much money you're going to need through that planning horizon. Okay, let's go back to the lecture notes. And basically here is a summary, and these 7 steps here is pretty much what I did. Plus, I did the carrying cost for each individual time period. So I did that also in Excel. I didn't do it here. This is a summary. Okay, so now let's, the last 2, let's go into chase demand with overtime. Okay. Oh, again, I forgot. Let me focus on this. And notice, where's the variability in the demand again? Is it in the labor capacity? No. No. The variability in the demand, where's the variability? It's over here in the inventory. So the labor is independent of demand variability, and the inventory is dependent on demand variability, because that variability will be seen in the inventory with level capacity. Okay, now let's add overtime. And overtime is a little bit more reasonable, practical. A lot of people use it. So consider the forecasted demand, capacity, productivity, and inventory summary from Excel. For this development, begin with 0 inventory, end with 0 inventory, no negative inventory is allowed. That's going to be important. You'll see in a minute. Now for this problem, let's have chase demand with overtime. Let's add a requirement. You have a maximum of 9 FTEs per month. Now this requirement, this additional requirement, is very common. You can't have unlimited workers. Quite often you only have a limited amount of workers to work in your company. And sometimes you have to get other capacity. You can get other capacity by hiring part-time people. You can have an outsourced. You can have subcontracting. You can have a joint venture. You can have all different kinds of things. What we're looking at is the greater capacity. With the same capacity, greater productivity with overtime. Okay. Again, now I have a 10-step procedure because there's more things going on. Okay. So down here, here's the summary. Okay, let me just show you a little bit what the summary is talking about. This is chase demand, and this is the maximum. So what I have here is my labor FTEs. I'll show you how to calculate this in just a second in Excel. And so therefore, I'm going to multiply these labor FTEs, times my my production standard. Remember, my production standard is 100 items per month. I multiply these by 100, and I have my regular time production. Well, this is my overtime production. And notice the first half up here, nothing is going on. But then I have overtime at the end of this planning horizon. So when I add these two together, this represents my production. So now my production is made up of regular time plus overtime. And so therefore my inventory is still 0 in this case. Okay. Let me show you how this is done. There's a little bit more, a few more steps here. Then this is just a summary of the solution. Let's bring Excel back and let's go through it. Okay, down here is chase demand with overtime. Okay, first of all, here's my demand. So here's my demand. Okay, so now notice this box right here, this shaded box. This is how I'm determining what my capacity should be. So what should it be? Well, now I don't have unlimited amount of capacity. I'm capped. I have a cap of 9 per month. So here's the process here. Let me bring over my initial production units. I call it initial because it may or may not be what I'm going to be producing. Okay, here's my production standard, again, 100 items, units per month. I divide to get my labor. So this is how much labor, here's how many FTEs I actually need. And notice some are below 9, some are above 9. Well, since 9 is my maximum, I cannot go above 9. So what am I going to do? Well, max FTE is 9 here. So the FTEs that I can actually use, this is my max. Over here is my allowed, is going to be 876. That's fine. But 12, 16, 11 cannot be more than 9. So this represents my actual capacity. So notice this capacity here is not necessarily exactly like my FTE directly from my chase demand production, initial production plan. But it's chasing it. It's not exactly equal to it because at the end of the time horizon, the planning horizon, it's just level, it's constant. But it's still referred to as chase because I started with chase and then added constraints and added conditions and requirements. Okay, so since this is my labor, what's my productivity? Well, again, I multiply this times my production standard over here. And notice here, this is going to be 8. Oh, here it is. Let's move it over here. This is going to be, here's my regular time production in units. Let's just zero this out. This simply equals 3 here, which is my production standard, times 6, which represents the amount of FTEs that I'm allowed to use. Let's do it again. Equals 100 times 7. And then copy it down. So notice this represents my regular time FTEs. Let's zero these out. Don't need those yet. So let's bring these over. So now I have my regular time. Well, I know my cost is going to be this, $16 per unit from above. And so now my regular time total cost will simply be how much I'm producing regular time. Whoops. Equals my unit cost times my production. Equals my unit cost times my production, and copy it down. Okay, now let's zero this out. Okay, now over here on the right, notice I have, let's take my inventory out here. Let's do my inventory again. We know it starts with 0. We know this equals the ending inventory up here. But this is going to equal my beginning inventory plus my production. But now my production is made up of regular time production plus my overtime production. minus my demand. My demand over here is way over here on 1. Okay, so I've done it. Let's do it again. Equals the beginning inventory plus my overtime production right here. I'm going to fill that in a minute. Plus my regular time production units right here. Minus my demand for this month is that point right there. Copy that down. I can copy both of these down now. And watch what happens. Boom, boom, boom. Okay. Since I have capped my capacity, bring it back. Since I've capped my capacity at 9, then what happens is that I don't have, notice my production here is 76,800, but my total demand is 6,000. Whoops, that's my cost. Here it is, 4,800. I'm sorry. My regular time production units is 4,800, but I have 6,000 total demand. I don't have enough productivity with this cap to satisfy my total demand. So where's that extra productivity coming from? Overtime. So the overtime then, here's my overtime production units right here. So I want overtime such that I do not have negative inventory. And there's where the negative inventory comes in. See, it's negative. Can't have that. So right here, the 3 is 0, so I can just say 0, 0, 0, 0, 0, 0. But right here, how much overtime production units do I need for this 300 to go away to 0? I need 300. And there it is. Oh, the next week it's 700. And then finally 200. And now I have my 0. And so here's my production, my regular time and overtime together. And that's what I did. Now notice in this right here, I went ahead, well, it's going to be convenient just to take my regular time production here, plus my overtime production here, and add it. And the reason I'm doing that is say, well, I could have used this number in my inventory, but I didn't. I used my regular time production here and my overtime production here. Okay, but the reason I'm doing this is look at my production here. My production actually is this, regular time and overtime together. But notice this production here for chase demand, okay, now it does equal my demand. But my regular time production does not. So in this case, when I add my regular time and overtime together, then my production does equal my demand. Okay, so all variability of my demand will be in my capacity here. Here's my capacity and my productivity. And my inventory over here is level. Now, let me just say in passing, it's not going to be part of this course, but you do not have to have these here, 3, 7, and 2. Let's take those out. What if I had 3, 7, and 2 up here? Okay, well, it's not 0, but it's not negative. So I could put it up here and all of a sudden I have inventory. Why would anyone want to do that? It's going to cost more. Well, when you have 0 inventory, then that increases the probability of stock out, which we'll talk about in just a second. Instead, we want 0, 0, 0, 300, 700, 200. Okay, so that's what we'll be doing in this course, in the homework, just to get used to it. But my point is, this overtime could be anywhere to increase this 0, because if I have inventory, that'll lower the probability of stock out. And so people want to balance your inventory cost with a stock out cost. Okay, and so now let's calculate the actual cost here. So I sum my regular time production, I sum my overtime production, I multiply by 16 times this equals 16, this times 16, and here this equals 1200 times 24. And there's my record time production direct labor cost and my overtime production direct labor cost. And over here, I'm going to have 0 inventory cost. Okay, and this is what I asked for in the homework. And that's how you do it. Okay, good. Let's come back to the lecture. We have one more, and so this is the 10 steps that I just went through. There's more steps to determine what the actual FTEs, your labor capacity, really needs to be. Okay, the last one is going to be level capacity with overtime. Okay, again, consider the forecasted demand, capacity, productivity, and inventory summary from Excel. Down here, there it is. For this development, begin with 0 inventory, end with 0 inventory. No negative inventory is allowed. And now we have level capacity, again with a maximum FTE per month of 9. So now it's the same as before, but I'm changing it to level capacity. Again, here's my 10-step procedure. And now I have 9 every time. But now I do have inventory over here. So let's go through this. Very similar to the one on chase demand, but let's do level capacity. Here it comes. Okay, again, here's my demand. And this right here represents determining what my capacity is going to be, which is this one right here. Okay, first of all, for level capacity, what did I do here? I'm going to go ahead and zero this out. Let's go through this. Again, remember for level capacity, I take the average of all of the demand. It's a very good way to start it. And this is going to equal this and copy down. There it is. My production standard is this. The labor that is needed then equals my production divided by my production standard, and that leaves me with my FTEs. Again, this divided by this is my FTEs. I copy this down, and those are my required FTEs. But now I have a cap of 9, FTEs. There they are. So the labor that I'm allowed, the actual labor, will have to be 9. Okay, and then coming over here, let's zero this out. Right here, my record time production equals, zero that out. That equals my 9 times my production standard. There it is. Again, it's 9 times my production standard. Copy that down. And there it is. Okay. I'll come back to this in a minute. I can sum this. And there it is. This is my record time production. There it is, 5,400. Each one of those costs $16 to produce. So down here, I'm going to have 5,400 times 16. I get 86,400. Or I can take 16 times each one of these. I could do this if I wanted to. Equals 16 times this. Equals 16 times this. Copy this down. And here, if I sum this, these are going to be the same. There they are. Okay, now we have our overtime. Well, let me zero these out again. Now, over here, my overtime, here's our inventory. We'll zero these out. Start with 0, and there it is. And this is going to equal the ending inventory of the previous time period. Here we go. This equals my beginning inventory plus my production. But now my production is made up of regular time production right here, plus my overtime production right there, minus my demand in the first time period, which is 800. So do it for the second month. That equals my beginning inventory plus my production, which is my regular time production, plus my overtime production right here, minus my demand for the second month, which is 700. Now I can copy both of these down. Now when I do, notice what happens. Boom, I have negative inventory. Why? Because I've capped this. I know I needed 10. I'm only allowed 9, so I'm not going to have enough capacity to meet the demand. I need a capacity of 10. When I only can use 9, I need overtime. How much overtime? Well, I can need overtime such that my inventory is not negative. So from my overtime into here, that's going to be a 0, 0, 0, 0. Now right here, I need 400. So I put 400. Right here, I need 200. So I put 200. And there it is. Okay, I sum my overtime units. 24, remember 24 up here is my my overtime labor, $24 per unit, okay? So I put that in there. Okay, so that's going to equal 600 overtime times the 24 is 1440. 14,400, 14.4K. Or I can put the 24 here and multiply that times my overtime. And there it is. I need $9,600 in that time period, 48 here. The sum is going to be the same as this. This is aggregate, and this is granular on every time period in the horizon. So this will be my regular time direct labor cost. This is my overtime direct labor cost. That's what I asked for in the homework. So this is just an example of how we would go about calculating level capacity with overtime. Okay, let's go back to the lecture. Okay, now some discussion. Finally, to end this a little bit. First of all, for this development, the beginning inventory was 0, the ending inventory was 0, no negative inventory is allowed. Now, let's go a little further. Negative inventory is called stock out. Stock out occurs when the demand cannot be met with inventory or your production. You can meet it either way. Therefore, stock out is unmet demand. We've already talked about that. But let's go a little deeper. The probability of stock out is called the stock out level. Now we're not going to be calculating probability in here. We do it in my other courses, but not in this course. The probability of stock out is called the stock out level, but the stock out level, that probability is used for risk analysis. It's used for strategic analysis, for tactics, for determining your inventory scheduling, production scheduling, and your capacity scheduling. Probability implies randomness and probability distributions, which require probabilistic modeling. Okay, so, well, it implies probability distributions. What's random? Well, demand is random. That's random. Cost is random. Carrying cost is random. And so there's a lot of randomness in the real world. And so that's where this would go deeper and go further in a course. This course would lay the foundation. And if you go deeper, extensions, we'll be looking at probabilistic modeling. 3, the beginning and ending inventory can be other than 0. When inventory is 0, the stock out level is high. Actually, it's the highest. Okay, because you just have one demand and all of a sudden you have stock out. To lower the stock out level, the beginning and ending inventory can be greater than 0. increase your inventory. Stock out is costly and not desired. Increasing inventory will lower the stock out level and likelihood or probability of stock out costs. What are stock out costs? Well, lost sales, lost customers, lost branding, lost market, lost image. So stock out costs are much, much higher than carrying the inventory. And that's why people carry a lot of inventory so they don't stock out. Because if you carry inventory, too much inventory, you're paying for that inventory. But if you lose a customer, that cost is lost forever. But increasing inventory increases carrying cost. Thus, a break-even is sought between the likelihood of stock-out costs and inventory carrying cost. And there's where this development goes, looking at inventory. The ending inventory does not have to equal beginning inventory. An ending inventory objective of increasing or decreasing beginning inventory can be used to achieve different business goals. If you start with 0, end with 100. Start with 200 and end with 100. So you can have different goals. Again, that's going beyond this course development. Production other than overtime can also be included in aggregate planning, which includes, but not limited to, outsourcing and subcontracting. Although these terms can be achieved in many ways, one simple approach is outsourcing can be described as moving work outside the company and delivered to the company. You outsource it. It says, could you do this for me and give me the results? Whereas subcontracting can be described as increasing inside capacity by moving outside capacity inside the company. Could you come in and do this for me in my company? So you subcontract it, but you subcontract it out so they're actually doing it in your, you still have control of it. And that's one description. There's other descriptions of outsourcing and there's other descriptions of subcontracting. But again, this productivity can be met in a lot of different ways. People get very creative on how to create productivity from capacity, either in-house or the capacity within your operation or outsourced. Okay, this development of aggregate planning is an introduction to the balance of forecasted demand with the operations that consist of capacity, inventory, and other resources to achieve multiple company objectives. In other words, all that 7 is just saying it's just an introduction. There's a lot more to it. But it's a good foundation. And I haven't used all the little details, all the details in the text. I think this is a much better foundation to start building on it. If you understand this, you can do the text. If you can do the text, you probably couldn't do all of this with production, with labor standards and production standards, etc., and FTEs. Okay, that's all I have for week 3 aggregate planning lecture. I hope this helps. Stay safe. Be very careful. Don't take anything for granted. Stay healthy so you can keep learning. Between now and the next time I see you, take care.